As you work through this video, don't forget to pause it in places to give yourself a chance to answer the questions and then see on the video if you've got them right. So what ions do all acids produce? Well, they produce hydrogen ions, H+ ions. Describe two ways of measuring the pH of a solution. Well, one way that you'll all be familiar with is using universal indicator solution. So you add a few drops of the solution and match the colour of the solution with the pH chart, and that will tell you the pH number. You might not have seen a pH probe. This is a machine with a sensor on one end which you place in the solution, and at the other end it will give you the readout of the pH number, often to 2 decimal places. So whereas the universal indicator solution might tell you the pH is 2, the pH probe would be more precise and might say 2.45. Question 1c. Hydrochloric acid is a strong acid. Suggest what pH number it could be. Well, if you see the word suggest in an exam question, it means there's several possible answers. So for a strong acid, it would be 0 or 1 or 2. They're all correct answers. Ethanoic acid is a weak acid, and we're given an equation there showing how ethanoic acid dissociates or breaks down or ionizes to produce the ethanoate ion and the hydrogen ion. How can you tell from the equation that this substance is an acid? Well, it's because it's producing hydrogen ions. All acids produce hydrogen ions. How can you tell from the equation that this substance is a weak acid? Well, if we look at the symbol in the middle, it shows an arrow that's going both ways. That means it's only partially dissociating or ionizing. So some of the acid breaks down to produce hydrogen ions, but some of those hydrogen ions will recombine with the ethanoate ion to turn back into the acid. So at any one time in the solution, some of it is as the acid and some of it as the hydrogen ion. It's not all broken down, it's only partially dissociated. What ions do alkalis produce? They all produce OH- ions, which are hydroxide ions. So we've got an equation here showing sodium hydroxide breaking down into sodium ions and hydroxide ions. Sodium hydroxide is classed as a strong alkali. Use the equation to explain why. Well, we can tell from that arrow that it's just going in one direction this time that it is fully dissociating or fully ionizing. And question C, suggest a pH number for sodium hydroxide. There's that word suggest again, which means there's several possible answers. And if it's a strong alkali, it would be pH 13 or 14. Question 3. Write an ionic equation to show the neutralization reaction between any acid and any alkali. Include the state symbols. Well, from any acid we're going to have hydrogen ions present. And from any alkali we're going to have hydroxide ions. When they combine, they produce water. So that would be for the first mark. Then the second mark, we need to add the state symbols. The two ions are in solution, so they get the AQ after them in subscript. And that means it's aqueous, or it's in water, or it's in a solution. Water we know is a liquid, so we put an L after that to show it's a liquid, and they're the state symbols. Question 4a. A solution of nitric acid has a concentration of hydrogen ions of 0.01 moles per dm cubed. What is its pH? Well, 0.01 can also be written as 1 times 10 to the minus 2 in standard form. And that minus 2 tells us it's pH 2. Question 4b. 0.005 moles of hydrochloric acid is dissolved in 50 centimeters cubed of water. Calculate the pH of the acid. Well, first of all, we need to realize that one molecule of hydrochloric acid gives up one hydrogen ion. So that means if we've got 0.005 moles of the acid, it will produce 0.005 moles of the hydrogen ions. But we need to work out the concentration of hydrogen ions in the 50 centimeters cubed of water. So we need to remember the equation for concentration. You won't be given that in your exam. Concentration is moles divided by volume in dm cubed. You also need to remember the conversion factor. to go from cm cubed to dm cubed, you divide by 1000. So 50 centimeters cubed becomes 0.05 dm cubed. That means the concentration is 0.005 moles divided by 0.05 dm cubed, and that works out at 0.1 moles per dm cubed. And if we change that into standard form, it's 1 times 10 to the minus 1, and the minus 1 tells us the solution is pH 1. If you're finding the video useful, just take a second to give it a quick like. Thank you. Okay, last question. 0.001 moles of sulfuric acid is dissolved in 20 centimeters cubed of water. Calculate the pH of the acid. Well, we need to realize this time that each molecule of sulfuric acid breaks down to release 2 hydrogen ions. So if we've got 0.001 moles of the acid, it will produce 0.002 moles of hydrogen ions. And then we go ahead and calculate the concentration of hydrogen ions. So the concentration is moles over volume in dm cubed. We need to convert again from cm cubed to dm cubed by dividing by 1000. So the 20 centimeters cubed becomes 0.02 dm cubed. That means the concentration of hydrogen ions is 0.002 moles divided by 0.02 dm cubed, which is 0.1 moles per dm cubed. We change that to standard form, which is 1 times 10 to the minus 1, and the minus 1 tells us it's pH 1. If you found it useful, please don't forget to subscribe so you don't miss out on my future videos. Thank you for watching.